Hello everyone, we are the Cosmic Insights, and today we are presenting our project Sustainability in Orbit, a report in traffic and risk in space. Let me start by introducing our team: Katia, Ashley, Kathryn, and myself, Esha. I'll start with a quick look at the numbers. Between 2020 and 2025, the number of satellites operating in Earth's orbit grew dramatically, and this growth continues to accelerate every year. But it's not just about the new launches. Inactive satellites in low Earth orbit can stay up there for centuries. Now, the Global Space Object Catalog does track thousands of satellites, rocket bodies, and debris fragments. The challenge is that the open data that's available is too fragmented and too complex to directly support decision making. That's where stakeholders need accessible and evidence-based insights. Our orbital traffic and risk report is designed to address exactly that. It brings together these insights to support policymakers in making well-informed decisions about space safety and environmental regulations.
We broke our project into 5 stages: gathering data and research, cleaning and processing data, exploratory data analysis, orbital traffic mapping, and conjunction risk modeling. We used various tools to complete the project, but primarily used Python libraries and Tableau for our analysis and visualizations. We pulled data from 2 main sources: the 18th Space Defense Squadron element sets, or LSETs, for precise orbital parameter data, and then the Space Track Satellite Catalog to identify other features about each satellite object in space. We started with 9 million rows of raw orbital data from January through August 2025, and after joining and cleaning the data, we had information on just over 29,000 satellite objects. From this, we built 32 features to make the data more interpretable, including things like orbit classification, debris-to-payload ratios by orbital shell, and more. These helped us deepen our understanding of the satellite objects during our EDA.
The vast majority of objects in space are payloads, outnumbering debris. There is a concentration of 85.35% of all tracked objects in low Earth orbit. LEO, typically defined as altitudes between 160 kilometers and 2,000 kilometers, is the most accessible and useful orbit for many critical applications. Added inclination to altitude transforms our view into a 3-dimensional model. A closer look reveals a dense band of objects across mid, polar, and retrograde inclinations. Satellite launches have not just grown, but have exploded exponentially since the 2010s. This surge is driven by the deployment of commercial satellite constellations, such as SpaceX's Starlink. The US is responsible for 49% majority of all tracked objects in space. This reflects the scale of US public and private activity, and also means the US bears a responsibility for leading efforts in space traffic management. Further, we zoom into details of the US objects. The numerous categories are private payload and debris. Starlink stands out. It single-handedly validates the earlier finding that private activity is leading US space presence.
We grouped satellites into 100-kilometer shells to see where they cluster and compare how crowded they are with one another. Due to the high density of objects and high debris-to-payload ratios in the 500 to 600-kilometer LEO shell, we decided to focus our conjunction risk modeling in this area.
In our setup phase, we defined the scope, customized the configuration, and built our propagators. Our orbital propagation model of choice is the SGP-4, used to predict the position and velocity of satellites over time. In our execution phase, we ran a coarse propagation, deduplicated rows, and then refined locally. For payload-to-payload conjunctions, over 5,000 events have missed distances below 1 kilometer. Following with 74 missed distances, conjunctions involving unknown objects should not be overlooked. Although debris and unknown objects contribute marginally, their presence still complicates risk management since they do not have the ability to perform avoidance maneuvers. Weighted risk is dominated by payloads at 98.6%. With first quartile missed distances lower than those of other objects, conjunctions between active operational satellites are both more frequent and riskier. We have the following recommendations. Establish binding international standards for conjunction assessment. Mandate maneuver protocols and thresholds. Classify unknown objects to better assess risk. Promote international agreements on information sharing, debris mitigation, and maneuver avoidance. Our team's biggest obstacle was our lack of domain knowledge in orbital mechanics and unfamiliar Python packages. To overcome, we spent a lot of time compiling space agency resources, watching videos, and creating schema tables. Thank you so much to Women in Data for hosting this datathon. We are really proud of what we produced. Thank you.